And finally, here we are at number 5. This combines everything that we looked at before. Did you notice that, again, we had a diprotic acid going on here? So it's really not 0.075 molarity of H2SO4. What you've really got is 0.15 molarity of the acid. And it's 120 and 120, so that's going to be, again, 120 2/40ths, or it's going to get cut in half of 0.15 molarity for my acid, and it's going to be 120 2/40ths of 0.075 molarity of my base, because, again, you're talking about strong acid, strong base situation. So this is going to be 0.075 molarity of your acid after it is cut in half, and that's going to be, what's half of 75? 37 and a half, 120 2/40ths of 0.075. So that's going to be 0.0375 molarity of your base. That's there. They are not equal to each other, and so consequently you are not going to have a pH of 7. The acid is more than the base, so when you're all done with this, you should see that the pH is below 7. Let's check it out. H positive plus OH negative goes to H2O. I've got an I, I got a C, and I got an E. I got a 0.075 here and a 0.0375 here, and a who cares, because it's a liquid. It's going to go over as far as it can go because water is a product, and our K value is 1 times 10 to the positive 14th because water is a product here. And so, consequently, you're going to see this as minus 0.0375 and minus 0.0375 to be left with 0.0375 here and 0. Once again, technically speaking, that is a lie. It's just a really small number. If I were to take then the negative log of that number, so again, remember our pH square, we've got the H positive and we've got the OH negative, and we've got the pH and we've got the POH, right? And all these guys are connected to each other. What you just determined here is that number here. So as soon as you know any one of the 4 corners, you now know all 4 of those corners. So like we talked about before, this is 0.0375 molarity that's there. And so if I take 0.0375 and take the negative log of it, I get a pH of 1.43, which then is going to get me a POH, not that I care, of 12.57. Negative, and then second function 10 to the guy there. That means this guy here is going to be 2.67 times 10 to the negative 13th. Now again, all they were asking for in this particular problem is what the pH is, so you could have stopped at this point here in red, the 143, but I just did all 4 corners for the sake of completeness. So again, that 0 there is really a lie. That 0 there that I'll put in orange is not really 0. It's just a ridiculously small number, 2.67 times 10 to the negative 13th, according to our equilibrium expression for the hydroxide that's there.